Every summer, millions of these end up on backyard grills. But are these different? Or if they just came in different packages? So I put all three under a microscope. Then I tried something completely new, and that's when things got weird. These are the three hot dogs we're testing today, you guys. Ballpark, Oscar Mayer, and Bar S. The funny thing is, all three are made with chicken and pork. So that got me wondering, if they're made from basically the same meats, are they really that different? There's only one way to find out. Let's put sample A under the microscope. Okay guys, you are now looking at a hot dog that's 40 times bigger than what it was. Crazy, right? So right away you can see that big brown chunk in the middle. That's the actual meat. Yeah, really it's meat, but those big circles floating around, those are just little air bubbles, so don't worry about that. So at 40 times, I'm really just getting a feel for the overall structure before we start zooming in. So now we're at 100 times magnification, and this is where things get crazy. You see that lighter streak running through the middle? That's actually muscle tissue. Can you believe it? Everything around it is a mixture of meat, fat, and connective tissue that's been processed all together. Even though this is a hot dog, you can still see parts of the original muscle if you look closely. So now we're at 400 times, and this is one of my favorite magnifications because you can really start seeing the muscle fibers. Notice how they all run in the same direction? That's called muscle striation, and that's exactly how muscle is built. I can't believe I'm saying this because it's in a hot dog, but there it is. So grinding and processing breaks a lot of that apart, but it doesn't completely erase it. It's pretty wild that you can still recognize it after everything this hot dog has been through. So now we're at 1,000 times, and this is the kind of stuff you never get to see with your own eyes. But here you are. That little yellow spot is most likely a tiny fat droplet, and everything around it is part of the protein structure that holds this hot dog together. At this point, it doesn't even look like food anymore. You're literally looking at the microscopic building blocks that make up this hot dog. Pretty crazy. So let's go to sample B, and this is all a mystery, you guys, because I'm not going to reveal the brand until the end of the video. Well, I know I need the average view duration, but let's make this fun. So I'll reveal the samples at the end. All right, guys, now we're looking at sample B at 40 times magnification on another hot dog. So the first thing I noticed is this one looks a little denser than sample A. You can still see the meat spread across the slide, but it doesn't look quite as open, right? So at this magnification, I'm just looking again at the overall layout before we start zooming in. So we're at 100 times, and here's where I started noticing the difference. Everything looks a little more blended together compared to the first sample. I'm not seeing those longer muscle streaks, which are striations, not standing out as much. So that doesn't automatically make it a better or worse, you guys. It just tells me this sample was processed a little bit differently. That's exactly why we're comparing all three. So at 1,000 times, we're getting all the way up. At this point, you're looking at details that are completely invisible to the naked eye, of course. So see all those tiny round pockets scattered around? Those are most likely little fat droplets mixed into the protein structure. One thing I did notice is that everything looks a little more uniform than sample A. It's pretty amazing to think that this sample B hot dog actually looks like under a microscope. Let's go to sample C. Okay, so here it is. The first thing I noticed was this one looks a lot darker than the other two, and everything just looks packed together. I don't really see those bigger open areas like I did before. So let's zoom in. Okay, well, I wasn't expecting that. You see this long string running across the screen? That's actually not part of the hot dog. So it could have been part of my slide prep or not, but that happens. The hot dog is actually these little chunks down there. You see it? So that's what I'm paying attention to. So let's bump it to 400 times, and at 400 times, things start looking completely different. You see all those little circles? Those are most likely tiny pockets of fat spread all throughout the meat. And one thing I'm noticing already, I'm not seeing those long muscle fibers that really stood out in sample A. This one just looks smoother. All right, guys, 1,000 times, we're looking at a hot dog that's 1,000 times bigger. It's scary, I know. It doesn't even look like food anymore. It almost looks like some weird alien landscape. And that's the part I love about microscopy. You can take something you've eaten your whole life, zoom in far enough, and it becomes something you've never seen before. So you know what? We're gonna go to the nematodes and see how they react to each sample. All right, guys, before we start this next experiment, I want to introduce you to these little guys. These are called Caenorhabditis elegans, or C. elegans for short. They're tiny transparent nematodes, only about 1 millimeter long, so you can actually fit several of them across the tip of a pencil. Even though they're incredibly small, they're actually one of the most studied animals in science. They don't have eyes and they don't have lungs, but they do have a mouth, a digestive system, muscles, and even a simple nervous system. They spend most of their time crawling around looking for bacteria to eat. When they do find food, they literally suck bacteria into their mouth using a muscular little throat called a pharynx. It's basically a tiny biological pump. Once they've eaten enough, they just keep moving until they find more food. They also reproduce incredibly fast. One adult can lay hundreds of eggs, and under the right conditions, an entire population can grow in just a few days. That's one of the reasons scientists have loved working with these little guys. Now, before anybody jumps to conclusions, this isn't a health test, and it doesn't tell us whether one hot dog is good for you or bad. I'm simply curious to see if these nematodes behave differently when each sample is introduced under the exact same conditions. Okay, so watch the left side part of your screen or TV. I'm going to introduce a solution, hot dog solution I mixed with distilled water. So watch this. So watch the jolt. Boom, there's a jolt. I just introduced the solution. Now watch, here comes the tsunami of hot dog juice. Here comes 10,000 gallons. There it is. See that, guys? 10,000 gallons of hot dog juice. So let's just see how they react to this. And they're right now, they're pretty quick, moving around. They know their environment has changed. So let's just watch these guys. Hey, check this guy out. I caught him at 400 times magnification. Pretty cool, huh? You can see actually inside of him, his digestive system going. And so let's keep going. All right, so a lot less activity going on with this slide. So it looks like they're slowing down. And there's a guy here, he's still going. He must be Captain America. But let's go ahead and move over to sample B hot dog juice and see how they fare. Okay, here's sample B nematode test. And yeah, I got a bunch on this one. So let's check this out and see how they do with sample B hot dog juice. Okay, I just introduced the solution on the left side, so watch the left part of your screen, and there it is, there's the tsunami. So let's watch their reaction and see how they fare. It looks like they know their environment's changed. All right, let me zoom in a little bit. Look at that guy. Either he has a lot of eggs in him or food. So let me keep scanning here and see what's going on with this magnification. But it seems like they're still moving. There's a few that are slowing down. You can see that. See the ones right there on the right? They're progressively getting slow. I think I would too if I had 3,000 gallons of hot dog juice dumped on me. So, okay guys, let's go to sample C, our last sample, and see how they do. All right, here it is, sample C nematode test. And watch the left side of your screen. And here comes, there it is, a tsunami. Watch their reaction. Again, 3,000 gallons of hot dog juice, lovely. So we'll see how they do. So I've been panning around for a good 15 minutes and they're still moving pretty good. Like those two guys. So yeah, I mean, this is different from sample A and sample B, but they're doing very well. Okay, let's get out of this microscopic world and get back to reality, and I'll let you know which samples are which. After looking at all three samples, here's what I found. Did you guys guess? Sample A turned out to be ballpark. Out of three, this was the only one where I can clearly see those muscle striations. Remember that? And honestly, I wasn't really expecting that from a hot dog. Sample B, did you guys guess? Was Oscar Mayer. It looked a little more blended together compared to ballpark, but it still had its own unique look under the microscope. And finally, sample C, did you guys guess? It was bar S. What really surprised me was the nematode test. Out of all the three samples, this was the only one where the nematodes didn't seem to slow down. That doesn't mean it's healthier, it doesn't mean it's better. It's just something I observed during this experiment, and I thought it was really interesting. Oh, before you guys go, I wanted to show you something that I've been working on for quite some time. When I first got into microscopy, I honestly wish I had something like this. It's not a giant textbook, just something that told me what I actually needed to know. Things like what I'm looking at, what stains I should use, what equipment I use, and why I use it. I've also had a bunch of you asking what microscope I use, what camera I use, what slides I buy, and the gear you see in all these videos. So I put all of that into this microscope field manual. The really cool part is, this isn't just a book, it's a living document. So every time I learn something new or I do a new experiment, I'll update it. And if you already own it, you'll get all those future updates completely free. So if you're interested, there's a link right below this video. Thanks for hanging out with me today. Be good to yourself and others.